Hello.
Hi, how are you?
Hi.
Do you hear me?
Yes.
Yep.
Yep, we can hear you.
Good, good. Once.
So everybody is okay now? Or the virus?
For now.
I hope so. Definitely, we are. I bet we are all are us under lock.
Yes, I
In
am
Poland,
now.
it's impossible to. It's well, everything is shut down.
Yes,
People
the
are
school is
closing
shut down.
phones.
Everybody work from home now, currently in the US, in Santa Clara. The
Ouch.
kids at
Yeah.
home make me crazy.
Do you have are you able to buy let's say, toilet paper? In Poland, it's
I
exhausted.
can't.
My mother asked me to buy for her.
I have some, I have some until now.
Yes, it's crazy.
Yeah, I think all the children. My mother asked all the children to buy her. She now is stocking toilet paper.
So guess we have a Chrome here. Oh, engine styling. Wait for a couple of seconds.
By the way, I'm using the new version of. I'm using the new version of Blue Jeans, which is supposed to have some whiteboard option. I didn't try it yet, but I know it exists.
You mean screen sharing?
Not exactly screen showing, something that is drawing together on a board, on a common whiteboard.
Okay, like a scratchboard.
Yes, yes.
Okay.
So where it is, should be somewhere.
Just a point of order. I'd like to reserve like a half an hour at the end to discuss the O-Node ordering thing, if that's all right.
Maybe we should start with it, no?
Okay,
either way.
cool. So
I think we can do status first.
last week,
Switch.
yeah. Well, let's keep the status quick and short. And last week I was still looking into the BinNode on the tree implementation, and have a couple discussion with the team, and did some code reviews, and that's it. And I'm done.
Yeah. Can you hear me?
Yeah.
Okay. So I looked at the you sent me. Be careful. I updated some stuff in the pull request of CBT according to Braddock's review and according to your review. And also, I was making some progress with the class to implement the function for the various plugins. I was actually implementing functions for CLS log, and when I wanted to test it, I actually found out that there was some sort of regression problem. So a while back, Radek made a pull request implementing some a function called the execute OSTO, and that we use it for the functions in object class, and that was in order to pass some CLSLO test. So basically, CLSLO is a very simple plugin like very simple functions. But now it appears that those functions don't really pass the test anymore. So I was basically just trying to fix that. I'm still doing a lot of debugging, and yeah, that's pretty much what I've been working on.
Let's wait a minute for Kifu. Are you back?
Yeah, I'm back. Thank you.
Okay.
Yeah. When did you disconnect?
Not here again. You're muted. Kifu.
Yeah, you're muted.
I learned that you updated your PR of CBT to address my comments and those from Redux.
Yeah, yes, and also I was making some progress with the object class implementation. I was implementing the necessary functions for CLS log, but then when I tested it, I've noticed that it's not passing the test, and was also not passing the very simple test of CLS hello, which was very weird because the last PR made to object classes it was actually passing those tests. So there seems to be some sort of a regression problem since the last PR. So I was just trying to analyze it and try to fix the problem out there. Still haven't found a solution. So basically CLSLO is like the most simple of plugin. Very simple functions. They're currently not working.
Have you thought about to exercise the test using testology-based test?
Sorry, can you repeat that?
Have you given thought to test the object class using the testology test?
Yeah, so I was testing. There is a dedicated unit test for each plugin. I was basically just running the dedicated test CLSLO that exists.
So we have a unit test for exercising them, right?
Yeah, I have there was an existing unit test. So what I'm saying is there was a PR made by Radek a while back. I can't remember. Maybe you can reference it here. For some implementations he did, sorry, in order for CLSLO. So basically implementing the necessary functions for CLSLO to work. And since then, those tests actually are not passing. It's regardless of of the changes I made. Because Radek was also running it on his machine and it's not been working out with the current master. So that's what I'm doing right now. I'm trying to analyze why it's not working.
I'm actually what I suggested to expand our test to cover more functionality we are implementing because you are mentioning the failure of test could be introduced by our recent change, right? It could be a regression. I'm wondering if we could add more tests, either in the unit test side or on the testology side.
Mm-hmm. Okay. Yeah.
Not much work updated this week. I just read your guys' design document and code. So do you have some task assigned to me so I can keep further on?
Not at this moment.
There's always a great deal to do in the internals of the OSD, right?
Yes, I think so.
Pardon?
Feel free to pick up any of the recovery work or any of the scrub work.
Recovery work.
or scrub work, anything you want to work on. There's a lot to fix inside of the OSD.
Oh, but I think Riddles and Shihan working on the recovery, right?
There's an enormous amount of it to do.
I think it's like there are a lot of hosts in the OSD, in Crimson OSD, in comparison to classical OSD. If you compare them functionality-wise, or performance-wise, or testability-wise.
Oh,
I mean, but you can also coordinate with Shuihan to work on the recovery stuff. Just in that area, there's a lot to do.
Oh, okay, I see.
Or with me
So,
on, or with
I
me
will talk
on,
with Shihan
Or
offline.
with on scrubbing. Or ping, and any of you guys can ping me if you need help splitting it up or have questions. I suggest that you coordinate on the document we started for recovery if you want to do recovery. Or scrub if you want to do scrub. Either way, it's a good idea to keep it in Google Docs just because we're all different time zones.
yes.
Oh, okay. So, I will talk with
Shihan
offline.
To split the task down if we have a better structure of how the problem looks like.
So
But
that's all.
one thing I'm sure is that a lot of things could be done in Crimson OSD.
Oh, I see.
Yeah, that's the thing. Only relatively little of the work will be in CStore or the Messenger. Most of it will be rewriting things that already exist in Classic. That was a choice we made by rewriting the OSD.
I see. Thank you.
Redak.
Oh, yes.
I've implemented the PD scanning feature, moved to backfill. However, in the second part of the previous week, I jumped for a second to the back counting for Octopus. There are 2 or 3 bugs I'm working on. One is two of them are about background issues. One is actually a quite nasty problem that was unveiled by DDP66 assertions. It seems that an optimization for empty string carrying in SED string leads all users of librados.so on Inserta07, which is quite old CentOS, leads to pre on BSS segment, which could lead to a memory corruption. Turns out that removing of our linker script, the part making all symbols in librados as local helps, but it could also be back in the toolchain. Anyway, I'm not able to replicate it on my local machine, which is Ubuntu LTS. So I'm going for tautology testing to verify how many platforms are affected. That's me.
Thank you, Redak. Ronan.
Hi everybody. I'm working on scrubbing. Started to write it down, write code down. What I'm doing now is rephrasing it as a state machine using state charts like what we currently have, Boost state charts.
Just one piece of caution. I have no idea what the runtime properties of Boost State Chart are. Not that scrub is usually a performance in the hot path, just so you're aware, I really have no idea how much memory it uses. With peering, we're kind of stuck with it because we weren't going to rewrite it, but yeah. Anyway, that's it.
Yeah, I must say that, well, I checked what data is available, and it seems that I don't think that will be a problem. It does affect compilation time, but
that I'm okay with.
Yeah, exactly. And by the way, in my previous project, I worked with the newer Boost state machines, which which are based on modern C++. And I'm very disillusioned now with boost state charts. It wasn't changed, I think, for 10 years now, something like that. And the age shows, its age is showing.
Well,
I'm not sure
like I said, you needn't use it if you can do something better. Up to you. It should be structured as a state machine because that makes it easier to read, but it doesn't literally need to use that library. That's all.
Okay. Because I thought that's the recommended library for us to use in.
No, that's what I'm saying. It works.
Not necessarily.
We're mostly okay with it. We're okay with it. It works. It's not a huge pain, but it's a little bit of a pain. If we had to do it over again, I'm not sure we'd use the same framework.
Okay, I would.
And peering isn't in the hot path, and neither is Scrub, so the performance properties are maybe not as important. But yeah, I mean, it does, if the way it's implemented generates a lot of garbage, that may not be the best. So I'm not sure. I guess I'm saying, I don't know. You'll have to evaluate and see what you think is the best option.
Okay. On the other hand, the Boost State Chart offers pretty good documenting features. You can very easily generate a graph from the source, and we are already using it in peering machines, so staying consistent might have some advantage here.
It's just that in order to do anything, I think you need to generate garbage, because I think all of the events and state machine things are dynamically allocated because they all need to inherit from the abstract bases required to make the templating work. So yeah, I'm just saying, if it doesn't seem like the right answer, don't feel like you have to. And it's not especially easy to read, what it's worth. Like, it's more advanced features where you have nested state machines. They work for peering because it's genuinely that complicated. Most of that is not incidental complexity, it's real complexity. There are a lot of events that really do logically get handled at more than one level of peering. But for things that are not as complicated as peering, that may be more work than we actually need to bother with. So.
Well, I tried to model first, before I started, I tried to model crabbing as a diagram. And there is value in having it in as a nested state machine.
Okay.
I
believe that nesting.
It's not mandatory. Sorry?
What I mean is that peering has events that are handled separately at multiple levels of the state machine hierarchy at the same time.
Mm-hmm.
Like advanced map, like the current get missing step looks at it for one specific thing, and then the peering state as a whole looks at it for a separate thing, and it gets forwarded up the stack for different reasons. So those features in Boost State Chart are helpful. It's not just that they're nested, it's that we actually care about the nested handling of events. So it's nice that they're polymorphic, it's helpful. But if that isn't so helpful to you, then maybe that isn't helpful. I'm just saying, I'm not saying don't use it, I'm just saying, use your, whatever you think is best.
Well, I think that compared to modern, I understand. I don't think nesting at that level exists in what we have in scrubbing now. There is some nesting, but it's not really terribly important. And I think I really think this is a very aging framework.
Yeah.
And it isn't. It's not easy to use compared to modern state machines. Okay, thanks. Thanks for the input. And that's what I've been doing this week.
Sam.
So I spent some time putting together a much more detailed explanation of what I see as the important parts of the unknown ordering and what I see as the variable parts, the parts we can discuss and design elements that have options. I think I wanted to frame the discussion first along sort of database design lines. What are we storing and what is the ordering we want to impose? And then secondly, once we've decided what that needs to be, we can start talking about how the on-disk structure can be optimized to serve that purpose and also avoid other problems. So anyway, I think we can discuss that at the end of this. That's what I've been working on.
Okay, we can come back later after the stand-up. And Johan.
Last week can you hear me?
I cannot.
Okay. Last week I was mostly spent most of my time debugging the peering issues that came up when OSDs with PG on it goes down and then up. Most of them is within the Alien store. But yesterday I found another issue. It seems to be caused by the fact that when OSD consume an OSD map, when OSD handles an OSD map message, that message could contain multiple OSD maps, but the OSD only consume the last one. So if there are OSD operations awaiting on a previous OSD map, then that operation never gets the future set. So it's just stuck there. I'm still not quite sure whether this is right. I'm trying to do some more debugging, and that's all for me.
I remember I looked at the OSD map gate. It will not be the problem. If the OSD map just jump several epochs, there's a map in the OSD map gate, and all the previous blockers will be fulfilled.
Oh, then I might be wrong, and I'm trying to do some more debug, and
okay,
that's it.
I think all the maps are supposed to be consumed by OSD and the PG meant by that OSD instead of the latest one.
Yeah.
Okay, so last week I'm working on the PR to fix a series of issues when I tested writes with multiple OSDs, and there is I left an issue for you guys if you are familiar with peering. I just record the log, error log in that issue page. So I will not diagnose it myself. And there's another issue left is a heartbeat racing problem, which involved 3 independent issues. I also explained that in this pull request, and I'm currently looking at a solution to deal with it, but I still need time to think it through. I will also after that I think I will also send a PR later to modify the Messenger Connect interface, and that's all.
Thanks. Or you can start talking about the owner tree then. Jenna? I'm going to...
I was muted that whole time. Sorry about that.
Okay.
Sorry, I was talking, but I was muted. Yingzhen, I wanted to ask you a couple of questions. So the first is, I believe you were proposing to add another 96 bits derived from the namespace and the OID. Is that true? Maybe not exactly 96, but some additional number of bits.
I think there's another option, but I give up.
No, I'm just asking him to clarify the comments he made later this evening. Can you hear me?
Are you asking me?
Yes, I am.
So could you repeat? I didn't quite get you.
Right. So I believe you are proposing that we add another 96 bits to increase the length of the hash derived from the namespace and the OID. Is that true? Okay. So my next question is, it's one of the ones you outlined. I'm just trying to clarify what that one means. So my question is, you mentioned a collision resolution mechanism, and I want to know what that mechanism is.
So the first character of the hash algorithm is that the collision is also random, right?
Yes, you have a pair of namespace and key, such that both the 32-bit hash and the subsequent 96-bit hash collide.
Yeah. So if some pairs of namespace and
let's just say one pair, what would happen inside of that OSD? Remember, they would be in the same PG.
So the collision will be easily handled if we just start to look at the first characters, because.
Okay, so I want to point out, so you're storing the characters of the namespace and the OID in the ONode tree.
Yeah, just enough characters to distinguish the collision.
How do you know how many you have to store?
So we can always fall back to some other. We can just reserve limited space with those.
But okay, Dingsman, you either wrote down the namespace and the OID the first time, or you didn't.
Sorry.
So does the ONode tree include the namespace and the key, or doesn't it?
When you insert an ONode, do you want to keep the namespace and object name in when you insert an ONode?
Why not? Can we? I think
I outlined a design whereby you literally don't. It just has the property that if there's a collision, everything stops working. It's a complete failure. So that is possible. There are systems that work that way. The application has to be careful not to allow collisions. I claim that isn't possible. So you do plan on storing the namespace and the OID.
So the ONode will also store the OID and the namespace.
That isn't necessarily true. There are OIDs that do not contain an object info, and they do not contain that.
So
now there are no librettos.
What I'm proposing is to resolve the names. If there are collision, we resolve the collision at the early stage of lookup.
I'm saying that there are two steps to a collision, two writes, right? You write the first object that's going to collide, and then many months later, you write the second object.
Then?
So what did you write down the first time?
Yes, the first time I will write down the object OID and namespace.
Okay, then I claim that your design is. I claim that you are arguing for version 2A for my document. It's just a longer hash. The purpose of the hash is just to speed up lookup. Great, thanks. So I think that is not a crazy thing to do, but I will point out that collisions aren't actually a problem in this case because we can handle them, and indeed we can handle them well. We just do the same thing every B tree does, and we index the strings. In your case, you're claiming that it's a rare collision, so for the most part, you just store them next to each other, and that's true. But I want to point out that if we do this correctly, it will even behave correctly if there are a lot of collisions. I wanted to point out that with RBD objects, via this little table I put down at the bottom, if we have 128 4 terabyte drives with 3x replication, we will have, with only the 32-bit hash, about one object for every 100 32-bit hash values. So in that event, the extra 96 bits are just wasted space. We didn't need them.
Yeah, that's the point.
That said, with RGW objects, which can easily be several orders of magnitude smaller, perhaps as small as 4K, that 1 in 100 becomes more like 10 to 1, which would be less efficient, right?
Mm-hmm.
So under those conditions, it might be valid to choose to pad out the hash. But I do want to point out that we're not replacing the variable size fields with a hash. We're just using a hash prefix to speed up the lookup. And all we're discussing is how long to make that hash. Do you agree with me there?
Yeah.
So the other things you brought up with efficiency of doing binary searches and cache efficiency, it is not necessarily the case that you have to store all of the fields of the node in each tree, in each level. I talked about that a little bit in this document, but obviously we'll have to go into a great deal more detail before we feel like it's complete. But I also wanted to point out that even in the event that you do need to store the variable size keys, you don't have to store them in line. You can use more of a columnar-based approach. Or something
what do you mean
even
by columnar-based?
So at this point, all we're doing is we're discussing the layout of the 4K block, right? So let's say we're storing some 20 keys, and there are a few of them that happen to share hashes, but the rest of them have distinct hashes. Your problem is that you want to optimize the search in the event that we're searching for something that actually is unique. It only has one hash value. So there are ways of setting up the O-node layout so that in those events you don't have to look at the strings. You'd only have to look at the strings if there are actually two of them with the same hash.
Yes.
So I want to point out that all of those things are true. I just want to make sure we totally agree on the fact that we're not going to fail to do lookups in the event of a collision. And that the thing that influences the size of the hash is simply a matter of reducing the number of the number of times we have to do key comparisons, string comparisons.
Mm-hmm.
Okay, so I think the next step, for one thing, you can just ask me questions about this, but also I think we should actually write down a concrete layout. I think that's the next step.
So are you still considering the key compression part you mentioned?
This is a bag of tricks. You will use a subset of them based on which things you choose to optimize for in the design. I haven't actually sat down and fully designed this out because there's more than one way to do it well. I actually think that you should choose a pretty simple approach, implement that, and then we'll have to, and then we can start prototyping improvements to it. Because different choices here will be good or bad depending on a number of factors, including how many objects are present on the OSD and how long the keys are. Because for one thing, RBD images have very short keys, but that's not true of RGW images. Or RBD blocks have very short keys, but RGW object names can be really long because the user controls them. We actually use Rados to do the lookup there as a distributed hash table. So it won't necessarily be the case that one layout is good for everything. We will want to prototype more than one option.
Okay.
As far as the key compression idea, I think the main thing here is just this is a way to do prefix compression. If you include the whole key, at least up to the suffix you're going to drop, in the very first key, you can then drop the common prefix for the subsequent ones if you adopt some encoding that makes that work. It can be as simple as a 1-byte prefix to each key that indicates how many fields are shared to something more sophisticated if you can come up with something better. They'll have different advantages and drawbacks, but the design space there is pretty big, I think.
Yes.
But do you agree with me on the core concept, I guess? What I see as the core concept is an agreement on what tuple we're storing and how it orders. Once we all agree on that, everything after that is a discussion of concrete on-disk layouts, and I think that's a long discussion which we'll entertain a lot of options on, but it's fundamentally much easier to change. As long as we agree on the basics.
So, I'm still not very sure about what you mean about the concrete things we need to achieve first. So So what do you mean by store, the layout of the...
Okay, so literally a B tree is like a set of, in this case, I'm guessing 4K blocks with each other's addresses in them.
Yes.
So when you open the block, you need to decode it, or at least have a way of locating a key within it. That's the layout.
Yes.
It can be as simple as a literal linear vector of beginning key pointer, beginning key pointer, beginning key pointer. But as you've pointed out, that with variable size keys, particularly in the leaves, that can be inefficient to search because you have to do a linear scan. So you can do a more complicated layout where you begin the node with a vector of the hashes of the crush ID part, and then a variable sized vector of strings for when you actually need to look at them, with some rule for when you go back and forth between the vectors, right?
Yes.
You can make the internal layout as complicated as you want, as long as we agree that ultimately you're storing a linear sequence of keys with these components. You may be omitting some of them because you have ways of compressing them out, but semantically, that's what it is.
Yes, this part I agree.
Okay, cool. In that case, I'm willing to entertain like a lot of different options for how to do the layout. I just wanted to make sure we agree on what the basic semantics should be. Mostly that, yeah, we have to write down the OID and the namespace. Because, like I said, there are designs where you don't do that, but they have this incredibly, like, catastrophic failure mode.
Yes, we actually need to write, record, at least store the OID and the...
And I do want to point out, just in case Radek, for instance, wanted to point this one out, we'll actually be duplicating the namespace and the key. And the reason for that is that every real Rados object has an object info attribute that includes the H object as one of its subfields. So I'm going to suggest that one of the very early optimizations we're going to make is we're going to drop that field from the object info because it's wasteful. It's a duplicate of the key, so we don't need it. And I think that's how we solve that problem.
Okay.
There are actually a lot of fields in the object info we're going to want to drop because it's way too big.
So could you write down exactly which field can be dropped down?
Okay, it's an optimization we're going to do. If you haven't looked closely into how the OSD actually uses it, then we'll worry about that later.
Okay.
Yeah, I don't think it's the critical at this.
No. That's a later problem.
Okay.
That is, we will arrange it so that the actual key in the onode index is the only place we bother to write down the namespace and the OID, so it's not wasteful. That's all. So I think it would be helpful if Yingxin, it sounds like you have a lot of thoughts on how you want to do the layout. Maybe for next week we could try to get a document with at least a sketch of like how the root internal and leaf nodes look. I would encourage you not to try to solve every problem. Try to go with a relatively simple approach. And then we can start brainstorming like, oh, this will work really well in general, but it's weak in these ways. So after we have this implementation, we might consider A, B, and C and see what happens to our throughput, that kind of thing.
Okay, so if I get into some unnecessary details, please point out.
Actually, I don't think unnecessary details are possible here because we're actually truly trying to game out exactly how the 4,096 bytes we have in each node map onto the keys we're storing in them.
Okay.
But remember, at the end of the day, you do have at your disposal the simplest possible solution, which is just a vector of keys with their corresponding pointers. You have to do a linear scan, but that's not the worst thing.
Yeah.
In other words, my goal here was simply to demonstrate that by adopting this approach, we haven't locked ourselves into something very inefficient. It's just that we will have to use some optimizations.
Yeah, I realized it yesterday. We have some leeways to improve the basic B plus tree implementation.
I'll point out that a B plus tree has side links, which we probably don't want to bother with.
No, I don't think we need it.
No, I mean, that's what makes a B plus tree a B plus tree. The plus refers to the side links.
Okay, I was thinking about the Prefix B plus tree.
You might also look at some other literature for how B trees have been designed. There are papers going back to the 60s. It's one of the oldest data structures there is. 70s?
Okay, we do.
Maybe it's not quite that old. Did anyone want to challenge my assertion that we need ordered listing for a backfill?
I think we already agreed that we just keep the ordering same within the Crimson OSDs, right?
Well, actually, okay. So I also wanted to point out that. So let me talk a little bit about compatibility. I don't think compatibility is a showstopper. Your analysis is correct. Generally speaking, Crimson isn't going to coexist long-term with classic OSD, OSDs. Moreover, this wouldn't be the first time we've changed the H object ordering. We've done it before. A while back, it wasn't. It was actually within file store.
It was.
So when I originally implemented, so you alluded to the fact that file systems have finite-sized or have pretty small max file names that are in fact much, much smaller than the maximum size of a Rados object name. Yeah. So back in the day, I implemented a scheme for creating a recursive folder structure so that we could efficiently list things in lexicographic order, despite the fact that ext4 and XFS do not in fact support that. And the way I chose to do that turned out to have something very stupid embedded in it. So when BlueStore came about, we didn't want to carry that stupidity forward. So we chose to change the ordering. It was actually a change in the byte ordering of the crush hash when used to list H objects. Semantically, it isn't really that different from what we'd be doing by increasing the size of the hash. So we've done it before. It's just that it's a giant pain. Because you do have to bubble it up to the H object structure itself, and the H object structure is exposed both through the backfill protocol and in Librados itself, though that interface is not widely used. So it is possible. I just don't want to do it now if we don't have to. And right now we're primarily targeting RBD. And as I mentioned here, for RBD, this isn't a critical problem. The extra 96 bits would just be storage overhead. It wouldn't help us.
Sam?
But in the future, we may wish to consider this for RGW.
My question, I'm not sure I understand, can we make it such a change without making it visible to user applications that
there are no user applications that rely on Librados's object listing. And if you're wondering how do we make it invisible to backfill and scrub, the answer is with a lot of work.
Okay, I don't care about anything inside.
Nothing external.
Anything. Okay.
Nothing external relies sensitively on the ordering. Not anymore. Rados GW used to.
But what you're saying is that we are sure that there are no user applications that it's visible to them.
I can't. Oh no, it's visible. I can't truly guarantee that there are no user applications out there that chose to link against Librados directly. Like, I'm aware that there's some project that uses Librados as like a mail backend. But honestly, we would just tell them it's going to happen, and there'd be a compatibility switch, and it would be their problem to deal with it.
Is this acceptable?
To an extent, Librados is not a purely internal interface, but neither is it we're married to this for the rest of our lives interface. It's intermediate. We'll never break CephFS the way it interfaces with userland. We'll never break that. We'll never break at a basic level the way RBD works with the various things that use it. But Librados's purpose is to be efficient for RBD, Rados GW, and CephFS. And like I said, it wouldn't be the first time. No one really complained last time. We'd mention on the mailing list to see if it bothers anyone.
That some object class could be using the internal interface of OSD, but that's another story.
I don't think so. Actually, I don't think so.
Is that
I don't think there are any class interfaces that expose PG list. Are there?
Well, there are
I mean,
some classes
some
that make
custom.
use of listing PGs, and moreover, they are even injecting some filter to manage the process of listing PG. Still,
Are you
I
certain?
don't think.
Are you
Sorry?
certain that it's not listing Rados GW objects in OMAP?
I'm pretty sure. I
Interesting.
implemented
Didn't
the
realize.
PG filter for PGLS and PGNLS CFOSD ops. They are
Yes,
used
but does anyone
in
actually
plugins.
use them? Also, I didn't
No, I
realize you
don't
exposed
think
those.
so.
Okay. I'm wondering because I think it probably doesn't work. PGLS and PGNLS ops, when they go through DoOp, have special rules. So it actually wouldn't surprise me if those interfaces are broken. But that's all of this is a digression. I think what I'm saying is Yingzhen is correct. We're not going to tie ourselves purely to the exact way in which listing currently works. The only thing that has to be true is that for backfill to work, all of the OSDs in the PG have to list the same way. That way doesn't have to be the way we currently list, except in the ways that I mentioned in the document. There is some freedom, but I don't see a reason to switch right now, is all. Does that make sense, Yingzhen?
Yeah.
Cool.
I saw that I'm not entirely sure that RGW is independent from the ordering. Well, I haven't made full statistical analysis, but I saw the listing code is used there, and it's used in many places. So I'm not sure. I just don't know.
Yeah, I was
It-
also
it- it-
even
it used
especially on this.
It used to genuinely matter because we used the Rados level listing to do bucket listing. But that
Okay.
was back in 2011. That was a long time ago. Even if it does do listing now, it most likely doesn't care about the ordering. It's likely doing it for GC purposes, which is very different. It's not important that we preserve ordering in that case. Anyway, like I said, it's a thing. If we were going to do it, it would be a huge pain, and we would have to do this exercise where we would have to go make sure have to make sure we do identify everyone who depends on it.
Exactly.
I'm just pointing out that it's been done once. That's all.
All I'm saying is that if we would like to talk with ordering on PG listing, we would need to spend a lot of time of RGW reading or make some experiments to verify
I don't want to right now. What I was saying is it's not impossible because we've done it before, but I also don't especially want to do it right now if we can avoid it, because it is a lot of work.
So Sam, do you have are you trying to make the conclusion that in the current developing phase, we need to keep the same order with classic OSD?
No, I'm saying it doesn't matter. I'm saying for RBD, it's actually beneficial to do so. Because for RBD, the extra 96 bits is just a waste of space. We weren't going to use them.
Mm-hmm.
However, it's not because compatibility is a problem. It's because it's not necessary or useful to. That's why. However, if at some point in the future it becomes helpful, it's not like we can't change it. It's just that right now it's not worth the trouble.
Mm-hmm.
And we may want to consider variable layouts. For instance, if we anticipate a pool having primarily 4 megabyte objects, then we wouldn't want to spend the extra 96 bits. But if we anticipate a pool having primarily 4K objects, well, more complicated. Actually, it's much more complicated because the extra 96 bits is however many additional bytes, which really eats into the percentage overhead per object. So even then, it might not be worth it. We might rather pay the CPU overhead than the storage overhead. So it's complicated. But
one
for now,
quick note
I think we can go with ordering. Go ahead.
One quick note on ordering and backfill. I think we could actually implement backfill in a way that is independent from the ordering, but it would have a pretty big price in terms of performance. I
Is
wouldn't
the
recommend
answer
that.
list all of the objects into memory?
Yeah.
Yeah, that's not an answer. Bluntly, it's not an answer at all.
No, we don't want to do that.
No, we don't. I'm just gonna flat out state that anything the OSD does that is linear in memory in the number of objects stored is absolutely a no-go. We need to be able to page things in and out of memory, or we'll have hard bounds on how much memory you can have per gigabyte of disk, which we'd really rather not have. It means, for instance, that like low density or high density, big ol' slow spinning disk in front of little ARM chip couldn't work, right? So we always have to be able to deal with objects in bite-sized pieces. You guys see what I mean?
Yes.
And how that relates to backfill? Okay. Cool.
So any other questions?
Or if anyone wants to start working on this design, feel free to ping me on a new doc and we can collaborate. Or whatever. Anyway, we think we can work on it. Works for me. This is exciting. Haven't done this before. A lot of options. Go ahead, Keith. Sorry.
Okay.
Or just add to this
quick
document
question.
would be fine too. Go ahead.
In the discussion, I saw there are some mentions about CPU cache usage for when doing lookups over ONODE tree, and I'm just one thing I would like to point out is that till we don't have any batching, I would assume that the blocks, the 4K or 8K or the ONODE tree nodes will be in the CPU cache. Likely there will be a cache miss on doing even at the top layer of the tree.
Interestingly, it's not just cache misses. It's not just cache misses and hits you're interested there. It's efficiency. So let's say, so the classic example, let's say you're trying to search a vector of pairs of integers and integers. So if you store the pairs of integers together, then let's say they're 4-byte integers, right? For every 8 bytes you read 1 key. By contrast, if you segregate them into 2 distinct vectors with the keys first followed by the values, then as you scan the first vector, you get twice as much throughput when you're searching the keys, and then you only need 1 additional read to get the corresponding value. It's not just about hits and misses; it's about read efficiency and locality. It's doubly true when you're doing binary searches.
One second. You don't want to do the references. Still,
it's not a reference. It's not a reference, Reddick. It's a deterministic calculation.
I mean,
go ahead.
I've understood you about you are thinking about the referencing memory, right?
No, I'm talking about the number of keys you get per cache line.
Okay,
This is a really common property of search.
Okay.
This is a really common property of search algorithms. It's not about the cache hit versus cache miss. It's about density and false sharing, but mostly density.
But cache density actually translates into cache misses and cache hits.
Sort of, but mostly it just changes the total number of cache operations, period. That's the important part. I'm telling you that it's not affected by batching. Not in this example, anyway. Doesn't matter.
But I think the cache batching could help with the density of data, the density of the index.
When I say batching, locality. I specifically mean C-star batching, which I think is what you meant, right, Keith? Or right, Reddick?
I mean having multiple insertions, multiple lookups over the tree in one turn.
Oh, I see what you mean. Actually, it will do that pretty frequently. This layout will make it likely that LBAs for an object are close together. So when you're doing LBA lookups for a single object, they won't be randomly spread over the LBA space. They'll be localized. Is that what you meant?
Yeah.
However, I think in this document, when we were talking about GPU cache lines, it was about density of keys per cache line. Because you want as few cache operations per search as possible.
Yep, I think so, yep.
Is that a
Yes.
fair statement, Lisa?
Yeah, just like RBD, we have less objects, so the keys can be smaller, so the density can be increased. So that's why. But RGW, there are many more objects, so we might need a longer key. So the keys will be less density, have less density. So those two cases can be conflict to each other.
There's it's a little more complicated even than that. There's enough information in this document, I think, to piece the rest of it together. But even in that case, for internal nodes, you only ever need to include the portion of the key that's actually different.
Yes.
From an information density point of view. So even that, it's not as hard a limit as it seems like it would be. The limit's only at the leaf, where you actually do have to write down at least enough of the key to make sure you can reconstruct it.
So if we need to write down the keys to the leaf, we might have many replications there. Do you mean that?
No, what I mean is, I guess what I'm saying is, while the key is longer, it's only longer once. It's not longer at every level. That's all.
Yeah. Okay.
Any further questions? Okay, let's continue the discussion over the shared Google Doc, and see you next week. And have a good day and have a good night.
Talk to you later.
See you later.
Thank you.
Thank you.
Bye.
See you.
Bye-bye.
See you.